you have an arc of a circle, part of a circle called arc, and you want to find electric field due to this uniformly charged arc at its own center. What do you mean by at its own center? That means if you actually take that as radius, the circle will be complete. Okay. So the arc is subtending an angle phi at the center. Note the total angle subtended by the entire arc is phi. That's why I've written the phi in between the middle line, because it's the total angle. Okay. Lambda is the linear charge density. Fair enough. What do I do? Take an element. All right, take an element. I took a small element at an angle theta, at a small angle d theta with radius with element dx. Why did I do that? Because I can see a possibility of solving it in a trigonometric or a polar integral involving theta, then geometry. My bad. Then algebra, x. So basically what you did was you assumed a dx very small arc. If it's a small arc, the angle it subtends is also small. And arc is equal to angle into radius. So your dx very small angle, a very small arc is equal to rd theta. Is this clear or not? Perfect. This dx is rd theta. All right. How far is it away from point P? All the points on the arc are radius away from point P. There you go. So what's the formula? K Q by R square. K, who plays Q? dq. What is dq? Lambda dx, right? So lambda dx by R square. But what is dx equal to? Rd theta. So one of the R in the numerator gets cancelled with one of the R in the denominator, and you are left with what? K lambda by Rd theta. How simple. K constant, lambda constant, R constant. What's left is d theta. Beautiful. Add all of them, sir. No, you can't. Because all the DEs are in different directions. So do what? Divide and rule. This is kind of like our salute now, right? Code. What to do now? Divide and rule. So the mirror image of your element. The mirror image of your element. Why mirror image, sir? Reason. Every point will have a mirror image except the central point. But in the first central point, the field is anyways along the x-axis. So every element has a mirror image, and if I break down both of them simultaneously, what's happening is that they will cancel their y component each time, and the x component will get added. That means by default there will be no y field at all. Hence the entire field, or so-called the effective component of the electric field, is only along the x-axis, and that component, my friends, is dEx. And if I integrate dEx, will I get the net field? Yes, I will. Perfect. Good. So dEx is k lambda by r cos theta d theta. Ex is integration minus phi by 2 to plus phi by 2. Hold on. Instead of minus phi by 2 to plus phi by 2, could I have done twice of 0 to phi by 2? Yes. Since the lower half is absolute symmetry to the upper half, you could have done that. But it's the same thing, okay? So k lambda by r cos theta minus phi by 2 to plus phi by 2. On doing that, what happens? Sin theta is the integration. Sin phi by 2 minus sin of minus phi by 2. Minus comes out. It becomes 2k lambda by r sin phi by 2. For a circular arc of linear charge density lambda and subtending an angle phi at its own center, the electric field is 2k lambda by r sin phi by 2. So what do I say the direction is? X-axis? Y-axis? What is that one thing which no confusion can enter into? Radially outwards for a positive charge and radially inwards for a negative charge. So the field is 2k lambda by r sin of phi by 2 radially outwards.